Today, we're going to be going through the process that I'll be following to create some sort of an animation. We're going to end up with this particular animation. However, I have no idea what it looks like because we're going to be building it from scratch together. Unlike my previous video where I actually gave myself a time limit, in today's video, I'm not going to be giving myself a time limit so that you can actually see the entire process, thoughts, and what might go on in a creator's head when they try and figure out what they're going to be creating for that particular day's tutorial. With that, do remember that even though this isn't technically going to be a tutorial, I will be going exactly step by step. I will explain why I'm doing what I'm doing, so it can be treated just like a tutorial. With that, let's actually begin this particular video. To start off, we see that the time is currently 3:03 a.m. So I will be editing out all of the gaps and times that it takes for Blender to render, but let's see how long it takes for me to actually finish creating an entire animation from scratch. So the first thing that I know is that I want it to be some sort of a tunnel loop because I've been creating quite a few of those recently. So I want to see how many variations of a tunnel loop I can make. So let's go ahead and first create the tunnel. Let's bring my cursor to the junction of these two windows, click and drag to create a new window and change this to the geometry node editor. Now I'll press this plus button to create a new geometry node tree, and I'll zoom in, I'll select the group input, and I'll tap X to delete it. Now I've made previous tunnels where we had circular tunnels, I've made tunnels where we had square tunnels, but I've never actually played with a triangular tunnel. So let's go ahead and press Shift A and search for a curved line, and let's plug that into the group output. Now I want this to be on the y-axis, so I'll change this z value to 0, and I'll change the y-axis value to a value of maybe 10 units so that the entire loop will be 10 units long. Now let's see, I can convert this into a triangle by simply searching for curve to mesh node, and for the profile curve, I'll actually just use curve circle and I'll plug that into the profile curve. Now I'll change the resolution down to 3, and that's going to give me the triangular loop. Now I think I'll have to rotate this quite a bit, so let's search for a rotate geometry node, but that does not exist. We have to search for a transform geometry node and plug that in over here. Let's maybe rotate it about the y-axis till we get it flat. And actually, instead of having an entire plane like this, maybe I want this to be sections. I just want triangles that I can twist over time. I think that'll look much cooler. So let's remove this, let's get rid of this as well as this, and let's search for a resample curve node, plug that in right here. And let's search for an instance on points. And for the points, let's search for a curve circle. Now let's make this circle triangular and plug this curve into the instance. And now we have to rotate this appropriately. So we have to rotate it on the y-axis by 90 degrees and okay, maybe minus 90 degrees. And then let's rotate it on the z-axis by 90 degrees as well. So now we have these triangles. I can increase the count accordingly, but let's keep the count at maybe 15 for now. Next, I want these to rotate about the y-axis based on this position. I think that'll look good. So let's search for a rotate instances node, plug that in right here. And for the rotation, I want to rotate only the y-axis. Let's just make sure that, no, it's not the y-axis. This is taking the local space. If I switch this off, it'll take the global space and we're going to get the y-axis. So that works. If I want to use the local space, then I think it'll be the z-axis. Yeah, that's correct. But I'll keep the local space off. I'll keep the z at 0 and I'll just use the global y-axis itself. Now I want these to rotate based on their index numbers or the y position. I think both of them will work. Let's search for a position node, and now let's search for the y position. So let's press Shift and search for a separate XYZ node so that I get just the y position from here. Now I know that the y positions go from 0 all the way to 10, and I need to map that between 0 to pi radians. So let's press Shift A and search for a map range node. Now let's go from a value of 0 to 10 all the way to a value of 0 to 2 star pi so that we get one full rotation. Let's plug this result into the y value of the rotation. So to get just the y value of the rotation, I'll have to search for a combine XYZ node and then plug this result into the y socket and this vector into the rotation. Okay, that looks like it's working. We are getting the correct rotation, but I think this is way too far. We have to maybe increase this count, and that looks better. But okay, because these are triangles, we know that the symmetry occurs every 120 degrees. So I don't need this to turn by 360 degrees. Maybe I'll just rotate it 1/3 of the way, which is 120 degrees, which should be 2 pi divided by 3. So let's make this as 2 pi divided by 3. So just divide this number by 3. And now we have this. This looks much better. Let's reduce the count again. Maybe make it a count of 20. And yeah, that seems fine. Now that we have all of these curves, let's go ahead and give them some thickness. So let's press Shift A and search for a curve to mesh node. Plug that in right here. For the profile curve, let's use a curve circle and then plug that into the profile curve. Now, okay, this is way too thick. So let's reduce the radius down to maybe 0.01. And that seems fine enough. Now, okay, this might be fine for the tunnel if we move the camera through, but obviously I think I'm going to require some sort of background. So let's add in some background as well. So let's press Shift A and search for a join geometry, plug that in right here. And let's think about what sort of background can use. Could keep it as a circular background. We could keep maybe an inverted triangle, maybe a square. Those are probably what would work. And let's just try a few of them out and see which one works better. So let's press Shift A and search for another curve to mesh node. And now I'm going to take this original curve itself, plug that into the curve to mesh. Maybe I'll take it on top. Let's plug this here. Now for the profile curve, I can use either a square or a circle or a triangle. So let's search for a curved circle. Let's take this and plug this into the profile curve and take this mesh and plug that into the join geometry. Now this is what it looks like if we just have a circle around the borders. Let's take our camera, press Alt G to clear location, Alt R to clear rotation, followed by RX90 to rotate the camera on the x-axis by 90 degrees. Now let's press 0 to go into our camera view and then actually look at what this looks like. So I think that actually works, but if we are using a circle, there's going to be a lot more geometry. So maybe we could just use a square. So let's select this and reduce this resolution down to maybe 4 to create a square. And this actually creates a diamond. I don't want that. So instead of a curved circle, I'll use a curved quadrilateral, and this quadrilateral will create a nice little square. Let's plug that in. And okay, that looks good, but I need it to not be shaded smooth. So let's press Shift A and search for a set shade smooth node, plug that in right here and switch off the shade smooth. And of course, this should be after the curved mesh. So let's Alt select it with the node wrangler enabled to just remove it from that connection. And then we can just plug it in here. And that looks all right. It doesn't look too great, but I think this is what we'll use. Maybe we'll increase the width and the height to maybe 4 units so that it becomes much wider. And I'll make this camera focal length also a bit wider. So I'll change this to maybe 25 units. And I think that looks much better. Maybe for this cube, instead of having flat walls, I'll just make it a greeble-like texture. I've done that multiple times on this channel before by just distributing some points on faces and then instancing some cubes on those points. So now let's press Shift A, search for an instance on points node, plug that in right there after the distribute points on faces. And for the instance, let's just search for a cube and let's plug that into the instance. Now, of course, we're going to have to scale these up randomly. So let's use a random value for the scale. It'll have to be a random vector. So we're going to search for the random value node. I'll switch it from float to vector, and maybe I'll keep the min values as 0.2 on all of the axes. The max value can remain at 1. Let's plug this into the scale and see what it looks like. Okay, that looks perfectly all right, but I still think that we can add in some more to make this look more alive, because right now we have these thin lines and it just looks like we're passing through a simple corridor. So let's go ahead and maybe add in some points within this volume. So we can do that by using a mesh to volume and then distributing points within the volume. So let's do that. Let's press Shift A and search for a mesh to volume node, and we're going to use this particular mesh itself, the entire cube, which is present over here. So let's take this, plug that into the mesh, take this volume output and plug that into the join geometry. Okay, I don't think that worked. Let's just distribute some points within this volume. So let's search for a distribute points in volume node, plug that in right here, and we should see some points. Maybe I should switch out overlays. No. Okay, fine. So wait, let me just see if we can just fill caps. Yeah, I fused. Oh, okay, fine. Okay, yeah. So that was what was happening. Because we hadn't filled caps, this wasn't an enclosed region. So because it wasn't enclosed, we weren't able to instance points within the volume. Like the volume wasn't being created. So that's actually simple to fix. Let's just duplicate this curve to mesh node, use this fill caps, plug this quadrilateral into the profile curve, use this original curve line as the curve. And now we can take this and convert this into a volume by plugging this in right here. So that seems to be perfectly all right. Let's go back into our camera view. Now we have some points within the volume. Let's go ahead and make these actual objects. So let's search for an instance on points node. Let's plug that in right here. And for the instance, let's just use an echosphere. Let's plug the mesh into the instance. And obviously we're going to have to reduce the radius. Let's change that to 0.2 and increase the subdivisions. Let's make that something like 3. And I think it has to be much smaller. So maybe a value of 0.05. And that seems good enough. Maybe let's go ahead and shade smooth, because if you actually zoom in, we're able to see all of the faces. So let's search for a set shade smooth node, plug that in right here, and that seems great. Now I think I'll start off with the actual loop before I start the materials. So let's press 0 to go out of my camera view. Let's select this entire object. I'll switch on overlay so that I can see it better. And I'll press Alt D to create a linked duplicate, followed by Y, followed by the length of each unit, which was 10 units. So let's do that. And now let's just press Shift R to repeat it 2 more times. Now that should be perfectly all right. We should have a perfect loop as we move through. To move through this particular loop, we're gonna have to select the camera and add in the keyframes. So let's go to our output properties, change this to maybe 200% so that we get a 4K animation. Frame rate, I'm going to choose 60 FPS so that it can render overnight. End frame I'm going to keep at 300 so that it's a 5-second long loop. Output folder, I'm going to store it wherever I save this blend file. File format, I'm going to choose FFmpeg video. The encoding, I'm going to change the container from Matroska to MPEG-4, and output quality as perceptually lossless. Now I'm going to expand the timeline by a little bit, and on frame 0, I'm going to go ahead and tap I, location. Then at frame 300, I'll just move it by the length of the tube, which means I'll have to press G, followed by Y, followed by 10, and then tap I, location. And of course, this is going to be Bezier to make it linear. Down here, I'll press T and choose linear. Also for the playback, I'll change it from play every frame to frame dropping so that we get a realistic idea of the speed at which we're moving. Now that looks absolutely fine, so I think I'll just go ahead and go with this. Although there is one thing that might be an issue. If we look at this particular set of objects, and let's just go to this last one, and we go to the next one over here, you see this particular object is being shared by both the instances. So when we select this instance, you can see that this particular triangle over here is highlighted. Let me just mark it over here. So this is the last triangle that is highlighted. Now if I go ahead and just select this set of objects, that one is still highlighted, which means there's actually 2 of these present at the junction. I don't want 2 of them to be present because that might cause shading issues later on. So to remove those, I'll just go ahead and delete the last instance. So over here we had the instance on points node, that's right over here where we instanced this particular triangle. So for this selection, we'll check if the last index is present, then it should be deleted. So let's press Shift A and search for an index node, and I have to check if the index is equal to this last value. And since we know that there are 20 points present on each line, the last index should be 19. Or instead of that, we can actually delete the first triangle for every single iteration. In that case, I just have to check that the index is 0, and I don't have to bother about this particular number because we can change it later on if we want, and it'll still work properly. So let's search for a compare node. Let's see if the index is equal to some value, but the indices are always integers. So let's change this from float to integer, and we want to see if it is not equal to 0, only then should it instance this curved circle. So let's plug that into the selection, and now that extra one should be deleted. If we select this, you see that this is no longer selected, which means there is no triangle instanced over here. So we've removed that duplicate, which is exactly what we wanted to do while maintaining the loop exactly as it was. So that's perfectly all right. Now there might be issues where we have these spheres coming too close to the camera. In this case, I don't think it's an issue, but maybe this one might actually interact with the camera. No, it doesn't. Okay, we're actually pretty lucky that it's not interacting with the camera at any point of time. But in case it does come within this contact region of the camera, I do want to delete any point that is present along the camera's path. So I'm going to use a technique that I've done again on this channel before. You can check out that video right over here. It'll be linked in the top right corner as well as in the description. I'm simply going to see the position of every single one of these points, and if it's lesser than a certain value, I will delete the point. So let's press Shift A, search for a position node, and I'll just place it right up to where all of my spheres were. So right over here. Now we want to check for the distance away from the y-axis. So we can do that by first getting rid of the y-axis altogether. Let's press Shift A and search for a vector math node, and we'll change this from add to multiply, and we'll multiply the y-axis value by a value of 0, whereas the x and the z will keep at a value of 1. Now let's take this position, plug it into the first socket, and now we can check for the length of the vector. So let's press Shift A, search for another vector math node, simply change this to length, and now we can plug this in, and we have to check if this value is less than a certain amount, then the points should be deleted. So let's search for a compare node, and we want to compare if this value is less than, let's say, 0.1, only then all of these points should be deleted. So we'll have a delete geometry present right there. Let's actually take all of this and shift it towards the side, and now shift this to the side as well, and then press Shift A, search for a delete geometry node, plug that in right here, and for the selection, let's use this result, and that should remove everything that's coming within the camera region. Let's just start increasing this by a bit, and you can see how particles that are there present too close to the center will be deleted. So maybe I'll keep it at 1.5 or 0.2 so that there's absolutely nothing that's going to come near my camera's view, and I think that looks absolutely perfect. Now I think that's good enough, but maybe I want to change the number of triangles that's present at some given point of time. So I want to automate that process as well. Right now, if I was to just go ahead and change the number of triangles using this resample curve node, will everything match up? Yeah, everything is matching up. So I think I'm going to keep it just like this itself. Once I start the shading, I'll actually play around with this number to get the correct count according to my needs. Let's go to my camera properties. Go to the actual object data properties tab. I'll expand viewport display and increase pass-par 2 all the way to 1 so that I don't see anything outside my camera view. Next, I'll switch my viewport shading to render, and I'll go ahead and hide my default light. Now, since I want there to be nice bloom and screen space reflections, I'll go to my render properties. I'll switch on bloom as well as screen space reflections, and I know that I'm going to keep very bright objects, so I'm going to expand this, and I'll just clamp this down at a value of 5, and I'll reduce the intensity to maybe 0.3. Now, for the screen space reflections, there is the refraction option. I don't know if I'm going to be using any glass objects, but maybe I'll make it such that all the spheres are glass. So for now, I'll just check this refraction box and let's go ahead and play around with these objects. So let's set the materials by going over just before this join geometry and then pressing Shift A and searching for a set material node. Let's plug 3 of them in by pressing Shift D and just dropping them in right like that. Next, we'll go to our material properties and we'll add in 3 different materials. So press this plus button 2 more times, press this new button to create 2 new materials, and let's rename these appropriately. So we have one material for the triangles, so let's rename this to triangles. Then we need one for the spheres, so let's call this spheres, and one for the walls, so let's call this walls. Now in this particular node tree, the output over here is the triangle. So let's go ahead and choose triangles over here. And then this particular node tree was the walls. So let's go ahead and select walls over here. Finally, this node tree is for the spheres. So let's select the spheres over here. Now let's go ahead and bring our cursor over here to change this from the geometry node editor to the shader editor. Let's start off with the triangles because I want those to be emissive. So let's select it, press period on our numpad to centralize the nodes. And I just want them to be emission. So let's delete the principled PSDF, press Shift A, search for an emission node. Now I want this to be lit randomly with different colors. So maybe I can search for an object info node, but no, object info node, I know it won't work. If we were to select this random value and use it for the color, or maybe we'll use it for the strength so that we can actually tell the difference in color. I cannot tell the difference in color. Okay, yeah, there are some that are lit very mildly. Maybe I'll just search for a color ramp node, plug that in right here and increase the contrast. Okay, that looks better. So let's see if we get a perfect loop. I know that we won't get a perfect loop because yeah, you see it's completely random. So on frame 300, we have this one lit, but on frame 0, this one is not lit, this one is lit. So we can't use this random value over here. We have to actually capture an attribute from within the geometry node section. So let's go back to the geometry node editor. Let's go ahead and press Shift A and search for a capture attribute node or a store named attribute so that we can use it in the shader editor. Now the triangles was over here. So I want to capture a random value for every single one of the triangles. So let's change this point to instance. And for the value, let's just search for a random value node, plug that in right here. The name we're going to choose maybe rand triangles. So RTRI, and let's just give it a random seed. Now let's go back to our shader editor and then we're going to go ahead and press Shift A, search for the attribute node. And since we were using it for instances, let's change this from geometry to instancer, and the name we're going to give as RTRI. Now if we plug this into the strength, let's see what we have. Again, it's too smooth. Let's just search for a color ramp, bring this in. Okay, yeah, that looks fine. And as we see, it is a perfect loop. So that's perfectly all right. See, between frame 300 and frame 0, there's no difference whatsoever. So it's a perfect loop. Let's go ahead and choose 2 different colors. Maybe I'll make this a combination of blue and pink. So let's select this, give it a bluish color, and let's select this one and give it maybe a pinkish color like that. Let's bring these in and this into the color. Now let's just increase the strength, and yes, that looks absolutely great, except obviously it's getting too bright at the center. We're going to remove that when we play around with the world settings, so we'll leave it just like that for now. Next, we'll go to the walls. I'll just go ahead and make them very metallic so that they reflect more light. I'll change this base color all the way to a white, and I'll reduce the roughness, or I'll actually use maybe a Chebyshev's texture for the roughness. Let's press Shift A, search for a Voronoi texture, and let's press Shift A, search for a color ramp node. Let's take this color, plug it into the factor. I'll change this from Euclidean to Chebyshev so that we get nice squares. Let's bring this in, and plug this into the roughness. Now, of course, I don't want any area to be completely rough or any area to be completely shiny. So let's select this, and instead of a value of 0, I'll make it maybe a value of 0.3 so that it's not too shiny. And this one, instead of a value of 1, I'll make it a value of 0.8. Now that looks great, and maybe I can change this scale to make it a little smaller. So I think that's all right. And maybe I can go ahead and give it some bump as well. So let's press Shift A, search for a bump node. Let's use this value, plug it into the height, and then take this normal value and plug it into the normal socket right there. Okay, I don't really see much of the bump, and that could be because we have this as a very low contrast. So I have to duplicate the color ramp node, or maybe instead of that, I'll just use the distance value. Maybe we can just plug the distance into the height, and that should give a nice fall off. It'll be much stronger as well. So yeah, that clearly works much better. Let's reduce this strength a lot. And yeah, I'll keep it at something like this, maybe a value of 0.45. I'll still duplicate the color ramp node so that I can just increase the contrast a bit, and that looks good. All right, now that I have the wall figured out, let's go ahead and play around with the spheres. So I wanted the spheres to be glass. So let's select the principled PSDF, tap X to delete it. Now press Shift A, search for a glass PSDF, plug that into the surface, and let's change the roughness to maybe 0.2. And of course, we're in Eevee, so let's bring this window down so that we can go to the settings, change the blend mode to alpha hashed and shadow mode to none. We'll also switch on screen space refractions, and the glass should look like glass. Now we are getting really good reflections and refractions. That looks really good, but I feel like they're too small to be seen at all. Maybe I need to increase the number of spheres that we have, but before that, I'll just get rid of this bright light at the back And to do that, I'll switch over to the world tab. I'll change the background to a complete black initially. Okay, that completely changes the look of everything. Let's just search for a volume scatter node and let's plug this into the volume socket of the world output. Okay, that instantly changes the look of everything. That makes these spheres far more noticeable, and I think that actually looks really good. But the walls are barely noticeable. Let's reduce this density down to 0.5, and yeah, now the walls are great, these spheres are great, everything looks amazing. I think this is all we need to do to create this render. Okay, although this looks great and I think this is good enough, I do want to try out one more thing. Maybe we could have these spheres take on these random colors and be all glowy, and have these actual triangles be made of a glass material. Let's just try that out. I'll save this as one version and then I'll start messing around with the other variation. So now let's go back to our object materials by switching this from world to object. Now for the spheres, I wanted these to have random values. So first I need to capture a random value for them. Let's go back to the geometry node editor. Let's just duplicate this store named attribute and random value nodes. Press Shift D to duplicate them and just plug them in right here. I'll go ahead and plug this in here, get rid of this connection and plug this in over here. Now I need to give this a different name. So I'll call this random spheres. So RSPHERE, and I'll give it a random seed as well. Now I'll switch over to the shader editor. For the spheres material itself, I'll just disconnect this glass material, press Shift D and search for an emission node. Let's plug that in right here. Press Shift A, search for the attribute node, switch this from geometry to instancer, choose that same name, and then I'm going to search for a color ramp node, choose the same colors that we had for the triangles. So maybe this sort of a pinkish color as well as this sort of a bluish color. Plug the color into the factor, plug this color into the color and increase the strength to some high value. Let's go with a value of 50. And even this looks good, I think, just by itself, where we have lit spheres as well as lit triangles, but maybe that's just a little bit too much of neon. So let's try out what happens if we change these triangles to a glass material. So let's switch over to triangles. Let's disconnect this connection, press Shift A and search for a glass BSDF, plug this in. Just like last time, we're going to have to change these blend modes. So I'll make it alpha hashed, shadow mode none, and I'll switch on screen space refractions. I'll increase the roughness to maybe 0.2 and I'll reduce the IOR to maybe 1.1. Okay, you can barely tell these. I think maybe we can just increase the radius of this curve. So let's go back to the geometry node editor. For the triangles, let's go ahead and just increase this radius. Okay, that is actually pretty weird, but wait, maybe I should just reduce this. Yeah, okay, so I've reduced the radius, I've reduced the resolution down to 3, maybe increase the radius a little bit more, and definitely increase the number of spheres that are present so that the scene becomes more lit. To increase the number of spheres, we can just increase the density over here. Let's make it a density of 5 and maybe reduce the size of the spheres. So okay, for the scale, I had it just as 1. Maybe I can just use some random values. So let's search for a random value node, plug that into the scale. And yeah, that instantly looks a lot better. I actually love the way this glass looks over here. These glass rods with the screen space refractions do look pretty cool. All of the tiny spheres are also refracting through it. The walls refracting through it. I like this loop as well. I don't know which one I like better. Maybe I'll just render both of them out and I'll put both of them in the video. But yeah, I guess that is the video for now, and I'll render these out and maybe I might make a few changes here and there, but that is essentially it. So on any normal day, I would have hit these for render and then started recording a tutorial after that, going step by step, explaining the process that I just figured out over here. However, hopefully you were able to recreate both variations through this particular video, and maybe this video was helpful. So with that, if you're ready, you can go ahead and press render animation. Okay, so now that I'm done, let's just take a look at the time. It's 3:42 a.m. So it took me approximately 40 minutes to figure out this particular loop. So I guess that's actually quite a bit of time, but if you actually watched so far into the video, thank you so much. I genuinely appreciate it, and your views and comments mean a lot to me. I post videos every single day. Normally they're tutorials where I go step by step explaining how to create different loops or just abstract animations or sci-fi animations, as well as sometimes I do create procedural materials and things like that. If you think any of that's going to be interesting to you, definitely check out other videos on my channel because I post videos every single day. Till my next video comes out tomorrow, thank you so much for watching. Keep creating and don't forget to stay creative.